Okay, in this video lesson, I'll be going over our lesson from multiplying and dividing rational expressions that we did in class on Wednesday, February 18th. So in this first one, you see we have two rational expressions. We have a fraction times another fraction, okay? So this is multiplication. So basically, we're just multiplying straight across, okay? But the very first thing we're going to do is factor any of these expressions that we can. So in this first fraction, the numerator and the denominator cannot really be factored. They're already in factored form. But in this second fraction, the numerator, x squared minus 1, well, that is the difference of squares. And we learn to factor that by adding the square root of both terms and subtracting. So the square root of 1 is 1, and the square root of x squared is x. So x plus 1, x minus 1 is how we factor difference of squares. If not familiar with that, you can look that up for further review. Then in this denominator here, x squared minus x minus c, so this is our ax squared plus bx plus c. We learned the x puzzle where we were looking for the factors of negative 2 that equal negative 1, and that was negative 2 times positive 1. So this factors into x minus 2, x minus 1. Again, if you need a review, that is factoring our quadratics in standard form, ax squared plus bx plus c. Okay, now that I have all of it in factored form, what we're looking for is any common factor in the numerator and the denominator that would cancel each other out. So this x minus 2 in the numerator and the denominator just cancel each other out. Same with the x plus 1 in the numerator and the denominator, they cancel each other out. So all you're left with is the x minus 1 in the numerator and the 4x cubed in the denominator, and that is all now factored, and that would be our solution, or that is what, when we multiply these two, that is the answer that we get. That is the product of this expression. Okay, number 2. Same thing, except for there's some additional factoring that we have to do. Okay, this first x squared minus x minus 30 factors into x minus 6, x plus 5, because negative 6 plus 5 is negative 1, and negative 6 times 5 is negative 30. In this denominator here, 5x plus 40, well, these two terms, or 5x and 40, have a common factor of 5. So we factor that out, and then what remains is what we would multiply 5 by to get back to 5x plus 40, so 5 times x and 5 times 8. Or these were the factors that remained. Okay, and then over here, 3x plus 6, same thing. They share a factor of 3. 3 will go into both of these terms, so we factor out the 3, and what's left is x plus 2, because 3 times x is 3x, and 3 times 2 is 6. And finally, in this trinomial down here, the factors of 10, that equals 7. Well, that's 5 times 2. And they're both positive, x plus 5, x plus 2. Then you start looking for your common factors. We cancel out x plus 5, and we cancel out x plus 2. Notice we're left with this 3 and this factor of x minus 6. So I've written 3 times x minus 6. And then down here we have 5 times x plus 8. Okay. Now this 3 over 5, if that was a fraction that could be simplified, we would need to do so, but 3/5 is a simplified fraction. So again, this is our product of this multiplication problem. All right, now, number 3 is division, okay? But please remember with division, the way that we divide fractions is we end up multiplying by what's called the reciprocal, or we just flip the fraction. Some of us learned it as keep, change, flip, but really you're just multiplying by the reciprocal. So I've rewritten the first fraction, but I have actually factored it, the factored form. So the factors of 30 that equal negative 11, that's 6 times 5. They're both negative, because when we add negative 6 and negative 5, we get negative 11. But when we multiply two negatives, we get 30, okay? And then over x plus 6. Then I changed it to multiplication. Then I flipped this fraction. So the 9x cubed went to the numerator, and then this original numerator got factored and put in the denominator as x minus 7, x minus 5, because negative 7 times negative 5 is positive 35, and when we add those factors, we get negative 12. Okay, so again, now we just have another multiplication problem, and you're factoring out the common factors. We have the x minus 5 and the x minus 6 that cancel. We're left with 9x cubed over x minus 7. Okay, let's just take a look at one more that we did in class. and that is number 4. Let's see here. So, okay, so let's pay attention here to x squared minus 4. This is the difference of two squares. The square root of x squared is x, and the square root of 4 is 2. So we add those factors, or we add the square roots and we subtract them. So x plus 2, x minus 2. That's how you factor this original x squared minus 4. This trinomial gets factored into x minus 9 times x minus 2, and then I change it to multiplication, and then I flip the fraction. So the x minus 9 is the numerator, and the 6x is the denominator. Then again, we cancel out our common factors of x minus 2 and x minus 9. We're left with x plus 2 times 6x, and that's our answer. Okay, 5 and 6 are on the back. We worked on these in class, but let me just go ahead. Or we worked on them together, or individually in class, or in our groups. The only difference in this one is that we ended up with a 3 over a 9 here in this answer, so we needed to simplify 3/9 to 1/3. So in my answer, I just wrote the factor of x plus 6, which was here, and then the 9 becomes a 3 because 3 goes into 9 3 times, so 3x squared. We could have simplified that here on the front end as well, but that's our final answer for that one. And then the final answer for number 6 is the x plus 4 over 2 times x minus 9. All right, that's a quick video. Hope that helps.